Find arc length. So the arc length, let's go ahead and draw a circle. Here's our little center. We'll say it's circle X. And let's go ahead and draw this arc here. So for finding arc length, it's probably what you thought about before. It's this part of the circumference is what we're measuring. So it's a distance between the 2 points, so between A and B in this example. So in order to find the arc length, if we think about this, well, this whole thing, right, all around, right, is their circumference, right? The whole distance is their circumference. So we need to think about that in terms of finding just this small portion of the circle. So we're just finding a smaller portion of the circumference. So to find the arc length, we're gonna actually use the circumference. So what's our circumference? It's 2 pi r. And then we're going to multiply it by this smaller part. So we only want one little small part. So if we actually think about it, if we only want this portion, right? That's all we care about. If we take the arc measure of the arc AB, divide that by 360, we're going to get that, just that portion of the circumference. So what we're doing is we're multiplying our circumference by a fraction just to get that arc length of that arc. So that's our formula. So let's go ahead and start to solve. Example 1. Find the arc length of the arc FB in the circle A, given a radius of 5. So we're looking at right here. We're finding this arc length. So how do we solve, right? Arc length is equal to 2 pi r times, well, if we're doing the, right, we're doing the arc measure of arc of FB over 360 degrees. So notice that, right, this is measured in degrees and this is measured in degrees. So that's why when we get arc length, we actually don't get degrees, because these cross out from one another. When one's on top and one's on the bottom, they just cancel out. So that's why length is going to be left in, right, given from our 2 pi r from the circumference. So let's go over what we know. So we know the radius r is equal to 5, and we know the measure, the arc measure is from here 60 degrees. So let's go ahead and plug that in. So we get 2 pi and then 5 times 60 over 360. So let's go ahead and simplify a little bit. So we get 2 pi 5, right? This is all multiplied, times 60, and then we can just go ahead and divide everything by 360. So if we were to do that, right, this 2 pi times 5, well, that means we're going to times pi times 5 times 60. And what do we get? Well, we get 1,884.96, as we're going to round to the nearest hundredth. Then we need to go ahead and divide by 360. So that would be the next step. So let's just go ahead. And what do we get? Well, we get 5.23. So we'll round to the nearest hundredth. We get 5.24. And we really don't know what it's in, so we can just say units. It could be centimeters, it could be inches, it could be meters, we're not sure, so we're just going to put units just to clarify that this is in a length. So we're not sure what that is, but it's whatever units it is, it's 5.24. So that's the arc length of this portion. Now let's go ahead and do another example. Example 2. A typical pie has a diameter of 9 inches. If one was to cut the pie into 6 pieces, find the arc length of one piece of the pie. So let's go ahead and draw this out. So we have a pie. Right, this is going to be the diameter, which is equal to 9. Now we want to cut this into 6 pieces. So let's go ahead and if this is also so now we have 6 pieces. So what we're trying to find is just the measure of this arc length, or any one, but they're all going to be the same because it's implying that we're cutting this pie into 6 equal pieces. So let's go ahead and use our formula. Let's go ahead and, so we have 2 pi r times, so what do? We want the measure of the arc length. So let's just go ahead and just say it's AB. It could be anything you want. It could be XY. It doesn't. This problem is something where you get to fill it in. It's kind of there just to help you think about it. So now here we are. We have the measure of, say, AB, which is going to be over 360. So we're not sure what AB is at this moment. But let's go back and let's start to fill in our variables. So if r, what's r? Well, r is going to be half the diameter. So if we go 9 and divide it by 2, we get our radius. So we get 4.5. Now, we don't need, we have 2, we have pi, we know what that is. Now we need to know what the measure of AB is. So if you have, right, a full-on circle, we have 360 degrees. But what we're doing is we're cutting this into 6 parts. So 360 divided by 6 is equal to 60. So this means this is 60, this is 60, and this is 60, 60, 60, 60. And then if we add that all up, right, if you go 60 times 6, we get 360 degrees. So our measure of AB is going to be 60 degrees. So let's go ahead and fill this in. So we get 2 pi and then 4.5 times, and we're doing 60 over 360. Now, let's go ahead. Now, 2 times 4.5 is 9, and then pi, we're going to go times 60, and then divide by 360. So let's get our calculators out. So we have 9 times pi times 60, and then we're just going to go ahead and divide it by 360. And what do we get? We get 4.71. And this one actually does tell us that it's in inches, so this is in inches. So let's double check this and let's think about this in a different way. So if we know 4.71 is the arc length of just 1, so if we were to go ahead and go 4.71 times 6, so this is to check our answer. So let's go 4.71 times 6, what do we get? Well, we get 28.26. So that would be the circumference, right? If we add up all of the arc lengths of each piece, it's going to be 28.26. Well, we know the circumference is 2 pi r. So let's go ahead and fill that in. So if we know it's 2 times pi times r, which is 4.5, we get 28.27. Now, these are actually really similar, right? This 28.27, right, they just differ on the hundredth. And the reason is because we did a 4.71 rather than, because we rounded there. So if we didn't round and we kept that really long number and then multiplied it by 6, we probably would have ended up with something very similar to the circumference of 2 pi r. So that's the reason why it differs. But you can see how this little arc length, if we multiply it by all the other parts, all the other arc lengths, we get the full circumference.